Welcome students to experiment 1. In this lab we'll be looking at 3 different sections, the first being precipitation reactions, the second acid-base reactions, and the third some simple redox reactions. Let's get started. In part A of this experiment we'll be looking at some precipitation reactions. A precipitation reaction is one where an insoluble solid forms. We'll first step you through an example and then we'll look at some of the theory behind how you can predict a precipitate forming. In this example reaction, we have some silver nitrate, which I've poured about 2 mils of into this test tube. You can see it's colorless and clear. And what I'll do is I'll take my pipette, and from my working stock solution, I will dispense about 1 mil of sodium chloride into it. You can see it's also clear when we start, and by mixing the two, you should see a pretty rapid reaction. Looking at the reaction between sodium chloride and silver nitrate, we can first look at the reactants. Then, sticking them into solution, we can dissociate them into their constituent ions. Once that's done, we can rearrange them and recombine according to charge, remembering that opposites attract. Then finally, if we have our product species, we can use the solubility rules table to determine whether or not a precipitate forms. We know our first product was sodium nitrate, so looking at the list of ions on the left, we can see at the top that a nitrate is soluble in all cases, so we know that that's going to be aqueous. Looking at the other product, silver chloride, if we look down the list to the third row, we can see that the chloride ions are all soluble except for silver, lead, and mercury 2+. So we know that silver chloride will form a solid precipitate. Because each group will only have one pipette, it's important that you rinse between each solution so you avoid cross-contamination. You can do that by taking the pipette, drawing up some water, and then dispensing it out into a waste beaker. Repeat this 3 to 5 times. Litmus paper can be used to colorimetrically detect acids and bases. Blue litmus paper turns red in the presence of acid, and red litmus paper turns blue in the presence of base. So what I've set up here is a small grid of 3 different chemicals, and by dropping each one onto the red and blue litmus paper, hopefully we'll see which one is an acid or base. In addition to the litmus paper tests, you'll also use some indicators to test whether your solutions are acids or bases. In this case, we use the phenolphthalein indicator and the bromothymol blue indicator. I recommend setting up your test tubes with each of the solutions so you can simply add your indicator one after the next. So by adding a few drops, we should notice a color change quite rapidly, if at all, and record the color change. What we're going to do for the last part of part B is a simple acid-base reaction between sodium hydroxide and hydrochloric acid. So in a test tube, I'll measure out 2 milliliters of hydrochloric acid, which I've done with this measuring cylinder, add it to a test tube, along with a couple of drops of our phenolphthalein indicator. And then drop-wise, I'm going to add sodium hydroxide until I notice a color change, swirling all the while. In part C, we'll be looking at some redox reactions. Redox is a shortening of the words reduction and oxidation, and you can't have one without the other. At the start, your demonstrator will show you some of the reactions, and then you'll try your hand at your own. It's important when you're observing all of these reactions that you take note of all of your observations. This includes color changes, clarity, any effervescence, which you may observe as bubbling, as well as heat. All of these observations may be useful in determining what the reaction is that you're observing. To show you an example of what we expect with these redox reactions, I have an example here that will use iron filings, which I've already placed some of into this test tube, as well as some hydrochloric acid. It's about 2 molar. So to the iron filings, I'm going to drop in some of this hydrochloric acid and observe any changes. And I want to make sure they're covered entirely, and I'll just give them a bit of a shake. And I can see that immediately there is a change to a sort of brown color. And I'm not sure if you can pick that up on the camera, but there are a small amount of bubbles evolving as well. So there's some kind of a gas being produced in there. For the last part of part C, we're going to observe the reaction between potassium permanganate as we slowly add hydrogen peroxide. The way we'll do this is I've dispensed half a mil of potassium permanganate into this small measuring cylinder, which I'll transfer into this test tube in its entirety. You may want to wear gloves for this part because it is likely to stain. To this, you need to add 2 drops of the sulfuric acid with a pipette. And it's very important you add this in, otherwise your reaction likely won't progress. 2 or 3 drops is just fine. Then we will add dropwise hydrogen peroxide and observe changes until a total of approximately 2 mils of hydrogen peroxide have been added. Hopefully this video has been useful to you in highlighting some of the procedures you'll be expected to do when you come into the laboratory and helped provide a visual aid for you to go alongside your lab book. See you in the lab.